here's kind of the next step of this lecture on my behalf, right? So we're just covering theory as well as you guys are practicing some hands-on for your fundamentals of JavaScript. And so theory, right? We're on the theory, so go to Google if you want to kind of follow along, right? I'm just going to use the Mozilla Developer Network, MDN. Learn JavaScript. Okay, so if you do that Google search, you're going to find, at least on mine, it's the third link down, which is the JavaScript MDN web docs on JavaScript. Right? Third link for you guys? Yep, so let's click on the third link. So allow me to read this. I don't like reading to my students because I feel that you could read on your own. Certainly you can read on your own. However, allow me to go through this. JavaScript, not to be confused with Java, two very different things, right? We know this at this point, is a lightweight interpreted. So to hone in on the word interpreted, meaning you write JavaScript code and there's a piece of software that reads your code and has to try and understand it. Like, hey, I've got this let data equals a string, or is it a number? Like it interprets, right? The interpreter is in Chrome, it's known as the V8 engine, right? So that's kind of a cool name. It's a name worth remembering, right? V8, right? So any car guys in here or whatever, you know, you got a powerful engine, right? Inside of Chrome is this piece of software called V8. It's the interpreter in your browser. It says, or just in time compiled. A compiler, see, JavaScript, we don't compile our JavaScript. What does compiling mean? What does it mean to compile? Like in your C# class, you were compiling your code. Whether you realized it or not, you were compiling it.
This is basically convert what you just programmed into what the computer can actually understand.
Yeah, so that is correct. So compiling does a couple of things, and that's one, right? Compiling means that there's a piece of software that checks your code for errors. So when I think of compiling, that's what compiling is to me, right? Compiling is a piece of software that's looking for your typos, not your typos, your syntax errors, right? A compiler checks for syntax errors. And so that interpreter will also check your code for syntax errors, but what Jacob said is correct as well. It also takes the words that you wrote and converts it into what's called machine language, which is binary bits, ones and zeros, right? Ultimately, that's what your processor can understand, and that's how your processor will do mathematical operations and order of operations and all sorts of things. Okay, is it has to understand bits. Okay, so I'm trying to take my time through here because these words are meaningful, they mean something, and it's important as developers to understand what this is saying, in my view. JavaScript is a programming language with first-class functions. Boy, is that a fun concept. A programming language is said to have first-class functions when functions are treated like any other variable. Well, we've actually seen that. Like you can store a function in a variable. In JavaScript, here's something. You can pass functions as a variable to other functions. Did you hear me on that one? So we just talked about parameters. We know what a parameter is, and we know that we can pass a piece of data into a parameter. You can pass a function into a parameter because functions are treated as variables. That's what it means to be a first-class function. Functions can be treated like other variables. Kind of weird. It's different. It's certainly not the case in, C#. But that's what it means to be a programming language with first-class functions. Functions treated as variables. While it is most well known as a scripting language for web pages. Okay? Scripting language for web pages, that's what you guys did last semester. You took static HTML pages, you added JavaScript to it to make it the keyword of dynamic, right? You made your static pages dynamic with JavaScript. It says many non-browser environments also use it, such as Node. The other day up on that whiteboard, I wrote Node, backend, how you run JavaScript on a server using this software called Node. And so so JavaScript is a scripting language, but when you start using it to build applications, it is also a programming language, right? So a scripting language makes HTML dynamic. So it is true that it is a scripting language, but when you build software with it, it's a programming language, right? So understand the little difference there, the little nuance that is a scripting language, dynamic web pages, versus a programming language to build apps, to build software. Okay? It is true, JavaScript can build desktop apps, JavaScript can build mobile apps, JavaScript can build web applications. Right? JavaScript is a prototyped based, I like the word multi-paradigm. Multi-paradigm meaning, what's your paradigm? Object-oriented is your paradigm, right? When we studied C#, C# is an object-oriented paradigm. It's an object way of developing. Whereas JavaScript is both object-oriented, or you might hear it called object-based. It is object-oriented, object-based. It has classes and that kind of thing. But it's also a functional programming language. Because it's object-oriented and functional, multi-paradigm. Multi-paradigm, which that was always a head-scratcher to me. Like, hey, I understand object-oriented. What is JavaScript? It's multi-paradigm. Which is nice because if you come from an object-oriented background, you can kind of understand it. If you come from a functional background, you can kind of understand it. Right? If JavaScript isn't your first language, it helps people from different backgrounds. Single-threaded, which means it does one thing at a time. It kind of order of operations, kind of one execution, one statement at a time. One statement at a time. Single thread. There it is. Supporting object-oriented, imperative, and declarative example functional programming. Remember React? We said React is declarative. React is built on JavaScript. That is a declarative style. Okay? So hopefully some of that sunk in, right? What is JavaScript? I think it's an important conversation to have because we never went in this kind of deep in your first semester. At least I know when I taught it with you guys, I didn't go that deep. Okay, this paragraph will go a little bit quicker. JavaScript's dynamic capabilities include runtime object construction. So there are objects in JavaScript. We've demonstrated it. Variable parameter lists, function variables. We just saw function variables in my last code demonstration. Dynamic script creation, we saw some of that yesterday. Object introspection, okay, and source code recovery. JavaScript functions store their source code and can be retrieved through, okay, toString function. This section is dedicated to the JavaScript language itself and not the parts that are specific to web pages or other host environments. And so what we're about to like kind of learn is just about JavaScript language and not like Node or not React, anything specific there. Okay, back to some fundamental stuff here. The standards for JavaScript are the ECMAScript language specification. So I kind of think of ECMAScript as a synonym for JavaScript, right? To me, when you say ECMAScript, it is to say the version of JavaScript, right? So like you've got Windows, you got Windows 10, you got JavaScript, and you got ECMAScript 2015, right? So JavaScript versions are defined through the ECMAScript. Realizing that there's a new version of ECMAScript planned every year. Since 2015, a new version of ECMAScript is released with new JavaScript features. As soon as a browser implements a feature, we try to document it. This means there should be MDN documentation for most features. This is a good one. You've heard me say this before. Do not confuse JavaScript with Java. You just saw JavaScript can do all sorts of things. It's a scripting language, it's a programming language, it can build mobile apps and desktop apps. Java's a programming language. Java is an object-oriented programming language. It has some crossover in what it can do. It can build applications, right? Java came out in the 90s, okay? In Java, and I've said this before, Java was kind of viewed in the 90s as the holy grail of programming languages. It was like, oh my gosh, Java, object-oriented, code reusability, classes, inheritance, this is great, Java is amazing. JavaScript was originally called something else. I believe it was called LiveScript. It was not called JavaScript in the beginning. It was called LiveScript. And that Brandon Ike created it, right? And because Java itself was so popular, the people at Netscape, right? Netscape is where Brandon Ike worked. Netscape Navigator became Firefox, which you know today is Firefox. They rebranded LiveScript. They rebranded LiveScript into JavaScript just to cause confusion for beginners. Not really, obviously that was not the case, but that's what it does. Like so many people who don't know the difference are going to say, oh, yeah, that Java, you know, validation on my web page, front end, you know, like they're confusing the two. They don't, okay. However, the two programming languages have very different syntax, semantics, and use.
It really screws you up when you don't know they're different. You're Googling something.
Yeah.
Figure out a problem and it gives you JavaScript.
Oh yeah.
Java or
Yeah. Yeah. Definitely. Okay. We've kind of already covered JavaScript first steps and JavaScript building blocks, loops, if statements, and events. We've already kind of done this. Probably where we're going to start, not probably, where we are going to start next is on this JavaScript objects. I think you've seen JavaScript objects. I know you've seen JavaScript objects. but I'd like to go through JavaScript objects with you all. And so that's where, so before starting this module, you should have some familiarity with HTML, CSS. You're advised to work through that. You should also have some familiarity with JavaScript basics before you looked at objects in detail. Before attempting this module, go through the first steps and the building blocks again. We're pretty well ready for that. Okay, object basics. In the first article looking at JavaScript objects, we will look at fundamental object syntax and revisit some features we've already looked at earlier in the course, reiterating the fact that many of the features you've already dealt with are in fact objects. Let's go into object basics. Okay. Before diving into this, we've been going for a little bit. This is typically the time we take our first little morning break. We'll go ahead and do that. All right, so I went ahead and deleted my JavaScript to kind of start fresh, discussing objects. And as mentioned, I think yesterday, to start with an object, you declare a variable and put a set of curlies. And so you can do that. And this will create an object. Now there is, I think, another syntax, new object as such. Kind of does the same thing, but the syntax that's more concise is just set of curlies. So we've got this variable called person, which allows us to then go into the browser. And if you type in person and hit enter, you see you've got an object, and not much there. So then to expand on that, now objects, key value pairs. What does that look like? Something like first name colon Evan, last name Harris. Sure, that's the last name. So key first name separated by a colon, last name in quotes, single quotes. This is a key value pair. If you have multiple key value pairs, you separate them with commas. Okay, now, you know, you can do like this, and that works just as fine. Okay, so objects have key value pairs. They can have integers, sure, age of 30. How about I'll say favorite foods, sure. Man, GitHub Copilot's doing its thing. So notice this key value pair has a value of an array. Going back to the docs, you can kind of see that that's where they go. Say, hey, here's a name property with an array of strings. There's an age. There's a bio property. We haven't done this, which stores a function. There's an introduce self property, which has a value of a function. So let's do this. Let's put a introduce self property into our object. I don't think you've seen too much of that. Maybe a little bit. And by the way, when you have an object, the keyword this references the properties. Well, there is no name property. I'll say this first name. There is no array there. This dot last name. It's even optional at this point. You could just do first name, last name, but this dot is a little more readable in my opinion, because you're talking about the instance of the object person. Okay, so now that we have an object that's a little bit more complex.
Sorry, can you explain why you used this again?
Yeah, it's almost a one of those memes in programmer humor, So on Reddit, there's a programmer humor board. You guys familiar with that?
Mm-hmm.
Yeah, check it out. It's a very common thing. Like, I've been writing JavaScript for 20 years. I still don't know what this means, the keyword this. Because this can mean many different things. It simply means this object's first name. So when we have an array of objects, you have an array of people, everyone's going to have different first names. So this first names means what object are you referencing? What is their first name? Does that make sense? So right now, all of our people have the same first name, but if you've got 20 students and you're saying, what is this student's first name? It's like this instance's first name. So yeah, good question. What does this actually mean? And that's kind of a programmer joke because it's easy to confuse what that keyword means. Okay, so let's go back to the console, and our object is person dot, and here we say age, and I say enter, and you get 30. Person dot, let's just say favorite foods. You get an array returned. If I can hit enter, there we go. If I say person dot favorite foods sub 0, enter, you get a string of pizza. Person dot introduce self, which is a property. You can see that's a function which returns a console log. Now I think if I do person dot introduce self and put parentheses there, it'll actually execute that function. Right? So there, we kind of went through those conditions. Okay, now, worth pointing out, maybe you thought about it, maybe you didn't. In C#, in order to create an object, you had to have a class. Public class student. We didn't have to have a class here, right? We just got to whimsically create an object and create properties and create methods inside of there, and no class needed. Is that a good thing? What's the beauty of a class? The beauty of a class is that all your students have the same properties and the same methods. That's the beauty of a class. Is that all your classes that are all your objects that are instantiated from a class, they all look the same. Okay? I could go ahead and create another person. And this person too could have a completely different look. Just kind of like, now I've got a name property which stores an array, whereas this person had two different properties that's not an array, right? So object-oriented, you had to have a class first to create an object. That's not the case. Now, there are classes in JavaScript, so you can do that. You can create a class, and then you can create objects from that class. Okay, and then you would get that benefit of all your objects looking the same. Okay, but honestly, I don't see that as much as I just see, hey, like, I'm going to create an object and put some things in it. Like, it's looser. JavaScript is looser than C#. It's more flexible. It's nimble. What do you like? You might have your opinion on what's good and what's bad. You know, different developers have opinions. Different opinions. Okay, so they go in and they talk about keys versus value, right? They call it a member, right? Class members or object members. Members is just a more generic term. It's either a piece of data or it's a function. Well, there it is. It's either a property or a method, right? Same difference. Now, here's a different syntax, right? Introduce self. You could change the syntax, right? Introduce self. Get rid of the keyword function. Just do this. Right? So again, doing the same thing, I can still go into my console and I say person.introduce self, enter, and hi, I'm Evan Harris. All right. So from now on, okay, we'll use this syntax, and that's good. Okay. An object like this is referred to as an object literal, which you've used that language before, right? A literal value is something, it says here, we've literally coded the contents as we've come to create it. Like a string literal, you've heard of a string literal, we say var, let name equal, or let money equals. Okay. This is called a string literal. We've literally coded the value of the string. Okay, whereas a variable, you might do something like let money, and then you assign money equal to document.getElementById, something more dynamic like the text input dot value. This is not a literal value. This is dynamic, right? You're gonna get the value out of the text box, right? So a literal value, when we're coding these objects, these are object literals because we're literally coding them out as in our source code. So literal values is a very common programming term. This is different compared to objects instantiated from classes, which we'll look at later on. Okay, it is very common to create objects using object literals. I would agree with that. We're not even going to do it with a class, you know, all of our objects in this class are going to be using object literals. We're not even going to create a class that I can think of once, besides as we're going through this. When you want to transfer a series of structured related data items in some manner, for example, sending a request to a server to be put in a database. Yeah, here's some data, put it in an object, send it off to the server, store that in a database. We're going to do that. Sending a single object is much more efficient than sending several items individually, and it's easier to work with than an array when you want to identify individual items by name. So an object is a structure of data to store well, it's a structure to store your data, right? An array is a structure to store your data. When you have a complex thing with like a person that has not only pieces of data, but functions that could be associated with it, and subarrays, right? And maybe sub objects, right? Objects are generally a little bit more complex, whereas an array is like, hey, I got a bunch of the same thing. I got a bunch of ages that I want to store. It's a bunch of the same thing. You use an array, right? But when you're defining the thing itself, you're defining an object. I'm going to write that one down because you guys are zoning out on me a little bit. So I'm going to write this in a note, in a comment. When you define a thing, you use an object to store that thing's data. That thing's properties and methods. Okay, a piece of data is a property, the method is a behavior. Okay, so I use the word thing because in English, essentially we're talking about a noun, a person, place, or thing, right? A computer is a thing, a desk is a thing, a mouse is a thing. These are complex things. They all have properties and behaviors, right? So just from a software, you guys all want to write software, right? You got to know, hey, I got a bunch of data. Does this data belong in an array or does it belong in an object, right? If you're creating a thing, you're going to create an object. But if you have a bunch of the same things, right, that's where you have an array. You can have an array of objects, right? So if you have a bunch of the same thing, then you put that in an array. When you have a bunch of the same types, you use an array. Copilot's listening to me, right? But that's an important thing to know. Like, well, I don't know, I got some data. Does it go in an array or does it go in an object or what? Like, well, you got to think about it. Okay, so we kind of demonstrated how to put data in, right? But to get data out, you use dot notation. And so I can do console log and person dot first name. This is dot notation. Dot notation. Okay, so this is going to get a piece of data out. I can do a console log person dot introduce self. Okay, same thing, dot notation. And of course, there you go. If I refresh this, something is giving me back undefined line 18. It's giving me that. Oh, well, I'm not, let's see if I take that out so that goes away. That does go away. Console log person dot introduce self. If you guys do introduce self, do you get undefined there? It's interesting. Person dot introduce self. Yeah, something I'm coding is giving me. Yeah.
Got it.
You got the undefined, yeah.
Or I've got the export.
Oh, so it doesn't say undefined? It does or does not?
It does not.
Yeah, interesting. What did I do? Introduce self. Oh, this dot last name. Evan Harris, and then undefined. I just have something somewhere that's Do you have this syntax of introduce self? Did you update your?
Yeah.
You did? Yeah. Not important. I'm not going to harp on it, even though I am harping on it. I'm just not seeing where I'm making that mistake, but that's okay. So that's dot notation, how to access its properties and its methods. Okay, so now this is good. This is good. We have sub objects, right? We've got child objects, right? So again, kind of going into this, is this the best practice? Maybe not, but let's just go with it. We've got person object with a name property with a object subdocument or sub object. So let's refactor this a little bit. I'm going to refactor this to be name here, first Evan, last Harris. Now to access this, put a comma right here, right, to separate it out. Now to get down to my name, it's person.name.first. Person.name.first. So dot notation will get you there. There you go. You guys following along okay? Doing all right? Yep, good.
Could you scroll back up on slide?
I sure can. What part would you like to see?
The thing you just
The object right here?
Mm-hmm.
Yep.
So, and then you go inside, like it points, it runs this line twice. For some reason. That's why it's giving undefined.
Undefined, okay.
I don't know why.
Yeah.
Because it runs it once, does it, runs it a second time, goes in like a separate like DOM thing.
I'm going to just for the heck of it, I'll do person.introduce self at the end of this. Okay, so we're getting the first name out, the last name out, we're getting the age out, and introducing yourself. Okay, hi, I'm undefined, undefined. Now, let's go back. Because why? Because first name is no longer at that location. So I'm going to say this dot name dot first, this dot name dot last. And there we go. Hi, I'm Evan Harris. Evan Harris is 30 years old, and there's my funny undefined that is a little quirky, but that's okay. We're getting it, we're putting the data in. Now we have an object and we have a property with a sub-object, a child object, if you will. Okay, anybody need to see any part? We all good? Good, good, good. Okay, they show you how to get into the child document and how to change those changes that we changed. Okay, there's another notation besides the dot notation, which is bracket notation. Bracket notation offers one advantage that dot notation doesn't. So instead of person dot age, you can do person's, I would pronounce that person sub age. And so to kind of reflect this here, let's do that, right? Person sub, and then the name of the property, okay? Now in general, this syntax isn't as friendly, right? In general, this syntax isn't as friendly, but it offers one advantage, is that you can put, if you don't know the name of the property, like if you're receiving an object and you don't know the name of the property until runtime, you can put a variable in here that would be like prop name. And then that property name could be passed in, and so it can be a little bit more dynamic. Okay? But before we get to this, before we get to the point where this offers a benefit, let's just demonstrate that person sub age should still work, right? Evan Harris is still 30 years old. Right? So it's a different syntax, the bracket notation. In general, personally, I find it a little less easy to work with. I prefer the dot notation. However, there is one distinct advantage, which is accepting a property name dynamically at runtime. And there are cases in this class where we will do that. There are cases where we'll use this syntax. Now, if you guys have done, the free code camp, a lot of this stuff you've seen before, right? You've seen objects, you've seen the dot notation, you've seen bracket notation. You've seen this stuff, but it's the theory that we're going through. And person sub name sub first, again, we can kind of go into here. Now, this dot name first. You may not need the keyword this. There we go. Nope, first name. So this dot. I don't know that you can work with the bracket notation. Good question. Let's okay, here's an example of using a dynamic property name. So here they make a function called log property, and you send in either the name property or the age property. So this function doesn't care. And if you pass in the value name, it'll return Bob Smith. And if you pass in the property age, it'll be 32. And it's dynamic at runtime. You can pass in whatever you want. So let's kind of bring that function in and demonstrate that. I'm going to backspace my bracket notation and do this. Okay. So I'm going to use this function log property name, council log person sub property name. Okay. Now I'm going to call log property, and pass in the name property. So into this function comes a string called name, and it's going to log the person sub name, which will return the object. So you could see this is the benefit of using the bracket notation, is that it allows for a kind of a dynamic, you could pass it this or you could pass it that, and get some, there you go. So the console log is returning our object, first name Evan, last name Harris. However, if I say age, you get back the value of 30. So at runtime, the bracket notation offers that benefit that you don't get out of the dot notation. Okay, so we've made this person. We've given them an age, but maybe they've gotten a year older. So we can go person.age and modify the age, right? Pretty straightforward. And then if I call log property and age, I should get that modified age back. Okay, so putting data in, modifying the data, getting the data out. That is setting the properties. It's also dynamic. I could say person dot GPA equals 3.1. Right? Now there was no GPA on the object originally, but we added it. Right? And that's totally fine. And so if I log my property of GPA, we get the 3.1 back. So that's setting. Okay, and that's creating completely new members. Notice here, they add a function. Person.farewell, let's go ahead and add that, right? So after I add the GPA, I can also add a function. And we can do it like this syntax. Person.farewell, no, it doesn't like that. Okay, let's keep it this syntax. Why doesn't it like that? Let's see. Semicolon expected. Yeah. All right, let's keep it that way. So person.farewell. And so here we're calling log property. Here I'll call person.farewell. So I added a function after the fact, and here I'm calling that function. And there it calls the function by everybody. Okay, another benefit of the bracket notation. Let's read this one. One useful aspect of bracket notation is that it can be used to set not only member values dynamically, but member names too. So your object names. Let's say we wanted users to be able to store custom value types in their people data by typing the member name into inputs. So here we're getting like a value out of a text box, storing it in a variable, and then creating a property by whatever they typed in the text box and storing a value that they, right? So this is creating a dynamic property name. Not only a dynamic value, but a generic name. Not a generic, a dynamic name. Okay, I'm not going to code that one. All right, James, me and you, what is this? I got to pause the video and show the meme or something. Didn't find the meme. What is this? You may have noticed something slightly strange in our methods. Like, look at this one's. Introduce self. This.name sub0. You are probably wondering what this is. The this keyword refers to the current object the code is being written inside. So in this case, this is equivalent to person. So why not just write person instead? Well, when you only have to create a single object literal, it's not so useful. But you can create more than one. This enables you to use the same method definition for every object you create. Again, you've got 50 students. This dot name refers to that object's, that one student's first name. Let's illustrate. Person 1, person 2. This dot name refers to Chris. This dot name refers to that. In this case, person 1 introduced self, says I'm Chris. Person 2 says, hi, I'm Deputy? Deputy? Deepty? Sure. Even though the method's code is exactly the same in each case. This isn't hugely useful when you're writing object literals by hand, but it will be essential when we start using constructors to create more than one object from a single object definition. And that's the subject of the next section. So it's, you know, hey, we've got a class. That class has a constructor, and you're going to create 50 students from that one class. Here we go, introducing constructors. All right, we'll talk about constructors after a break. Okay, to kind of finish up this article, using constructors, right? And so even the word construction is building something, right? So you're building your object. Is when I think of a constructor, you're constructing the object. You're building the object. So that's what the word means to me. Using object literals is fine when you only need to create one object. But if you have to create more than one, they are seriously inadequate. We have to write out the same code for every object we create, and if we want to create some properties of the object like adding a height, then we have to remember to update every object. We would like a way to define the shape of an object, the set of methods and properties it can have, right? So when you're defining the look of something, that should seem really similar to this classes. However, before we get to classes, we're just going to learn how to do so with the constructor. And then create as many objects as we like, just updating the values for the properties that are different. Okay, the first version of this is just a function. Okay, so notice, let's take a look at this function. It's a function, it's called createPerson. It takes one input parameter called the person's name. We create an empty object. We assign that property of the name, that object's name property, equal to the value passed into the function. We then create a function called introduceSelf that logs out that person's name and returns the object. So this function creates an object, assigns a name, creates a function of that object, returns that. So let's kind of just rip that in here. And I'm just going to kind of start over, right? So here's our, I think the proper name for this is a factory function. Maybe you've heard of that. It's a factory. Like, you give it an input, it outputs a thing. A factory function, right? Const person equals createPerson calling Bob. Call then person introduce self. Hi, I'm Bob. And there we have it. Of course, then we could do const person2 is Alice. Person2 introduce self. Hi, I'm Alice. Now we have a template for what this object looks like. Right? And all of our objects are essentially, they have the same blueprint. We're creating a blueprint. This should seem really similar to what you did last semester. Right? If you guys want to code along, I'll kind of hold this here for a minute. While you're coding, again, I'll just highlight, maybe I didn't highlight this before. This object is being returned out of our factory function. That's why on the right-hand side we have a function call, and we're storing the return value inside of this variable called person. Right, so what is being returned is on the right, but it's being stored inside of a variable called person. Okay, to resume here, it says this function creates and returns a new object. Each time we call it, the object will have two members, the name and the introduce self method. Again, a member is either a property or a method, right? A member is just a generic word for property or method. Okay, there's one input parameter called name. This is a very common pattern for creating objects. That factory function is referred to as a design pattern. Okay, and then they do the same thing that we just did, creating two objects using that function. It says this works fine, but it's a bit long-winded. Programmer term, it's not even a programmer term, the word verbose comes to mind, right? Verbose means you're using too many words to describe a concept, right? You can code something that's too verbose, meaning you coded it in 100 lines and it could have been done in 5, you know. We have to create an empty object, initialize it, and return it. A better way is to use a constructor. A constructor is just a function, just like an object-oriented. A constructor is just a function. So a constructor is a function called using the new keyword. That's a little different. I mean, that's definitely different. When you call a constructor, it will create a new object, bind this to the new object, so you can refer to this in your constructor code, run code in the constructor, and return the new object. So let's talk about this one more time. A constructor is just a function called using the new keyword. So we haven't seen this keyword in JavaScript yet. Well, we have, but not around a constructor. When you call a constructor, it will create a new object, bind the keyword this to the new object, so you can refer to this in your constructor code, run the code in the constructor, of course, and return the object. Constructors by convention start with a capital letter and are named for the type of object they create. So we could rewrite our example like this: function person. So let's do this. Function person. We'll get rid of the word create. We're just going to say function person name. And then we don't have to do this anymore. We can set this dot name equals name. This dot introduce self equals function. And you do not have to return the object. Okay? So now we kind of take what we did and we make it a constructor instead, and it's a little less verbose. Again, it's a good thing. To call the person constructor, we use the keyword new. That's what I was thinking. All right, so here, person equals new person Bob and new person Alice. Hi, I'm Bob. Hi, I'm Alice. Okay, so that's the end of that section about using constructors. It says you've been using objects all along. You might remember that from last semester. You know, a string is an object. That's why you've got methods like split. There's all sorts of, you know, we're already using the dot notation last semester. So let's go through this. As you've been going through these examples, you've probably been thinking that the dot notation you've been using is familiar. That's because you've been using it throughout, you know, everything in JavaScript. Every time we've been working through an example that uses a built-in browser API or object, we've been using objects because such features are built using exactly the same kind of object structures that we've been looking at, albeit more complex ones than our own basic custom examples. So when you have myString.split, you have a string object. Every time you create a string in your code, the string is automatically created an instance of the string class and therefore has several common methods and properties available on it. When you access the DOM using lines like this, document create element, document query selector, you are using methods available on the document object. The same is true for arrays, the same is true for math, and so on. Note that built-in objects and APIs don't always create instances automatically. As an example, the Notifications API, which allows modern browsers to fire system notifications, requires you to instantiate an object using the constructor for each notification you want to fire. Try entering the following into your console. Well, I think that's what was supposed to happen. That's a little weird demo. If you guys throw that in there, new notification hello, do you get undefined? I do. Anyone else get anything to happen there? Following along on that one? Okay. End of the article. Summary. Congratulations, you've reached the end of our objects article. You should now have a good idea how to work with objects in JavaScript, including creating your own objects. You should also appreciate objects are very useful as structures for storing related data and functionality. If you try to keep track of all the properties and methods in our person, objects let us keep information safely locked away in their own package out of harm's way. The next article will look at prototypes, which is a fundamental way that JavaScript let object inherit properties from other objects. So in JavaScript, we do have inheritance through this thing called prototypes. We don't hit this very heavy in this course, so I'm not going to go over prototypes. I'm going to stop this recording here.